Students, last class we have seen about aminoglycosides. This class will focus on the products of aminoglycosides. The first one is streptomycin. So it was isolated from actinomycin called Streptomyces griseus, and it was discovered in 1943 by Selman Abraham Waxman, and for that he got Nobel Prize in 1952. It is the first antibiotic effective against tuberculosis, and it is the first aminoglycoside antibiotic that was isolated from actinomycin bacteria, that is called Streptomyces griseus. And among the aminoglycosides, it is having lowest nephrotoxicity, and it is restricted only to the treatment of tuberculosis, and because of the resistance it is usually given in combination with other antibiotics. Now we will see the structure of streptomycin. It is having three parts, that is, one is N-methyl L-glucosamine, streptose and streptidin. Now come to N-methyl L-glucosamine. So without, here it is having NHCH, without that it is having OH, means that is called as glucose, that is called L-glucose. So in the case of L-glucose, that OH is replaced by NH2, means that is called as L-glucosamine. Glucose with NH2, that's why it is called glucosamine. Here with the nitrogen only the methyl is attached, that's why it is called N-methyl L-glucosamine. And here it is having nitrogen, no, that is in the form of secondary amine. We have known primary amine means that is having NH2, secondary amine means that is having NH, tertiary means that is having N. So here it is having NH. So this is the amine is in the form of secondary amine, okay, and it is weakly basic. And look, come to this one, it is called streptose, and that is having aldehyde group and also hydroxy group. Here it is having methyl, and this one is called as streptidin, okay. This is called as guanidine. Already we have known NH2CONH2, no, that is called as urea. So instead of oxygen, here we have NH, means that is called as guanidine. So it is having this streptidin, no, that is having two guanidine groups. Because of the presence of these two guanidine groups, it is acting as a strongly basic one. It is a strong base. And now we will see the hydrolysis reaction of streptomycin. First we will see acid hydrolysis. So streptomycin, on hydrolysis what you are getting? First streptobiosamine plus streptidin. So this one, first we are getting streptobiosamine, the whole thing, plus streptidin. Then this streptobiosamine, no, that on hydrolysis we are getting these two products, that is N-methyl L-glucosamine plus streptose. And this one, no, that streptidin, this on hydrolysis we are getting streptamine. What is streptamine? Here we have guanidine, no, guanidine group, no, that would be hydrolyzed. So these two guanidines would be hydrolyzed, and this part is going, and here we have only NH2. So that is called as streptamine. Streptamine plus 2 molecules of carbon dioxide plus 4 molecules of ammonia. Streptomycin, on alkaline hydrolysis, maltol would be formed. Now we will see the chemistry of streptomycin. Already we have seen aminoglycosides or aminocyclitol antibiotics. So this nucleus is present in aminoglycosides. So what is that? Here that would be 1,3-diguanidinoinositol. This would be the structure of inositol. Inositol means 6-membered ring that is having 6 OH groups. Here this is called inositol. Here the first and third hydroxy groups are replaced by means of guanidine, means that is called as streptidin. That's why it is called 1,3-diguanidinoinositol, that is otherwise called streptidin or strepthadine. Okay, so what is the aminocyclitol moiety present here? That is called 1,3-diguanidinoinositol or streptidin, and that is the central ring present in streptomycin. Here already we have seen it is having two guanidino groups, and they are acting as a strong base, and we have a methyl amino group that is present in N-methyl glucosamine, no, that is the weakly basic one, and it is having one aldose sugar, that is called streptose, and that one is having hydroxyaldehyde, that is streptose, that is having hydroxyaldehyde, no, that is acting as a center of instability. So because of that the streptomycin cannot be sterilized by autoclaving. Already we have seen it is having two strong bases and one weak base. So because of that it is called triacidic base. Now we'll see the SAR of streptomycin. First we'll see about streptose. Streptose already we have seen, that is having an aldehyde group. If the aldehyde group undergoes reduction means we are getting alcohol. The name of that is dihydrostreptomycin, and its activity is similar to streptomycin. Both are having same activity, but it produces severe deafness. And if the aldehyde is oxidized to get oxime or semicarbazone or phenylhydrazone derivative mean, that results in an inactive compound. If the methyl group present in streptose is oxidized to methylene hydroxy group means active compound would be produced. Now we will see about N-methyl L-glucosamine. Already we have seen that is having amino-methyl group, that is methyl amino group. So that is essential for activity, and already we have seen that is secondary in nature. So that is very, very important. It should not be primary or tertiary. It should be only secondary. And now come to streptidine, that is having two guanidine groups. These are essential for activity. The replacement of guanidine groups decreases the activity. Now we will see the adverse effects of streptomycin. They are auditory disturbances, nephrotoxicity, hypersensitivity reactions, and superinfection. Now we will see the uses of streptomycin. They are in the treatment of tuberculosis, plague, subacute bacterial endocarditis, and tularemia. The next product under aminoglycoside is Kanamycin. So it was isolated in 1957 from Streptomyces kanamyceticus, and it is the second systemically used aminoglycoside, and it is having high toxicity while comparing with other aminoglycosides. While telling the name Kanamycin, actually it is a mixture of three components, that is Kanamycin A, B and C. Now we will see the structure of Kanamycin. Okay. And it is having three rings. The second ring, that can be called 2-deoxystreptamine. Already we have seen streptamine in streptomycin. So streptidine on hydrolysis we are getting streptamine. Streptamine means in that place there may be OH, that is called streptamine. Here that was absent, that's why it is called 2-deoxystreptamine. So second ring is called 2-deoxystreptamine, and the third one is called kenozamine. Okay, it is otherwise called, before that here in third position we have NH2, so instead of NH2 that may be OH means that is called as D-glucose. Here instead of OH only NH2 would be attached, that's why it is called 3-amino. Third OH is absent, that's why 3-deoxy D-glucose, otherwise it is called 3-D-glucosamine. So third ring is called as kenozamine, otherwise called 3-amino 3-deoxy D-glucose, otherwise 3-D-glucosamine. So the rings second and third, these are common for the three kanamycins, but the first ring, that will be different for these three. Now we will see the structures. So now this is the structure of Kanamycin A. Already we have seen these two rings are common. Now come to this ring. Okay. So here without here we have NH2, instead of NH2 that may be OH means that is called D-glucose. Here what is attached in sixth position, what is attached instead of OH it is having NH2, that's why it is called 6-amino 6-deoxy D-glucose, that is present in Kanamycin A. So Kanamycin A is having ring 1 as 6-amino 6-deoxy D-glucose, whereas in the case of Kanamycin B, here in second position it is having OH and sixth position it is having NH2, but here second position NH2, sixth position as 2 and 6 are having 2 amino groups, that's why it is called 2,6-diamino 2,6-di-deoxy D-glucose, whereas in Kanamycin C second is having NH2 and 6 is having hydroxy group. Okay, so it is called 2-amino 2-deoxy D-glucose. So that is the only difference. So for ring, for Kanamycin A, the ring 1 is 6-amino. So 6-amino 6-deoxy D-glucose. For Kanamycin B, it is 2,6-diamino 2,6-di-deoxy D-glucose. For Kanamycin C, it is 2-amino 2-deoxy D-glucose. So Kanamycin A, that is otherwise called as Kanamycin. So if you are telling Kanamycin, that indicates only Kanamycin A. So the Kanamycins differ only in sugar moieties, that is attached to glycosidic oxygen on the fourth position. So this is the fourth position of the central ring. What is the central ring present here? 2-deoxy. So what is the difference between these three Kanamycins? First one, Kanamycin A is having ring 1 as 6 amino 6 deoxy D-glucose, whereas B is having 2,6 diamino 2,6 di-deoxy D-glucose, whereas C is having 2 amino 2 deoxy D-glucose. So here the Kanamycins know how they are differing. Only in the sugar moiety is attached to the glycosidic oxygen on 4th position of central ring. So this is the central ring. In here the 4th position would be attached with the ring 1. So that would be the only difference. The Kanamycin fragment linked glycosidically to the 6th position of deoxystreptomine is 3 amino, already we have seen Kanamycin, that is 3 amino 3 deoxy D-glucose, otherwise 3D-glucosamine, and all the 3 Kanamycins. It is basic and forms salts with acids to the amino group. Now we will see the uses. In the treatment of GI infections, dysentery and systemic gram-negative infections caused by Klebsiella and Protease. Now we will see Neomycin. So in 1949 it was isolated from Streptomyces fradiae along with Fradicin. Fradicin, that is an antifungal agent and used as an intestinal antiseptic. Now come to Neomycin. Actually it is a complex of antibiotics and it is having 3 biologically active substances. They are Neomycin A, B and C. Neomycin A, that is otherwise called Neomycin, and actually it is a disaccharide. And Neomycin B, that is found in greater abundance, and in that 3 this is the predominating one. And Neomycin B and C, they are having similar structure. Both are having same structure, but they differ only in stereochemistry, that is they differ only in orientation or configuration. Now we will see the structure of Neomycin B. So it is having 4 rings. So here this one is called as Neomycin C, and that is connected to deoxystreptomine by means of glycosidic linkage, and that one is connected with the D-ribose again. That would be linked glycosidically, and that is connected to Neomycin B. So it is having 4 parts: Neomycin C, deoxystreptomine, D-ribose and Neomycin B. And these two, combination of these two, that is Neomycin C and deoxystreptomine, that can be called as Neomycin, that is Neomycin A. And this D-ribose and Neomycin B, these two combinedly called neobiosamine. We said it is a Neomycin C, here. By replacing NH2 here, second and 6, by replacing NH2 by means of OH, we are getting D-glucose. Okay, so that's why it is called as 2,6-di-deoxy D-glucose. Already we have seen this in Kanamycin B. Okay, so this is called as 2,6-diamino 2,6-di-deoxy D-glucose. Here the amino methyl group attached in the 5th position, that is getting alpha configuration. But come to this one, that is Neomycin B, that is having similar structure, but here the amino methyl group attached to this position, 5th position, that is beta. Here this one is alpha, that is dotted, indicated as a dotted line, and this one is beta, indicated as a thick line. Both are having similar structure, but they differ only in configuration. Here the parent for this one is called D-glucose, whereas parent for this one is called L-idose. L-idose, that is an epimer of D-glucose. Both are having similar structure. Actually they are isomers, but they differ only in configuration. So the parent for this one is D-glucose and for this one is L-idose. That's why it is called 2,6. Second and 6th are having NH2 group. Okay, so 2,6-diamino 2,6-di-deoxy L-idose. So Neomycin B, otherwise called as 2,6-diamino 2,6-di-deoxy L-idose. For C it is D-glucose, same thing, but it is a D-glucose derivative. So it is a D-glucose one. So what are all present here? It is having 4 parts. Okay, this is for Neomycin B. Now come to Neomycin C. The 3 rings, that would be the same. And what about the last one? Here it is having Neomycin B, but this one would be Neomycin C. So what is the difference here? 5th position is having amino methyl group, that is connected by means of alpha configuration. Here for B it is beta configuration. For B it is beta configuration, for C it is alpha configuration. That is the only difference. Okay, so what is the difference between Neomycin B and C? By the nature of the sugar attached terminally to the D-ribose. that only they are varying. Actually, how they are varying? They differ only in configuration of amino methyl group in neosome, and that is linked to the ribose unit. If it is having alpha configuration, that is neomycin C. If it is having beta configuration, that is called neomycin B. Now neamine, already we have seen it is otherwise called as neomycin A. How we are getting neomycin A? Obtained by methanolysis of neomycin B and C. So here we have that neomycin B, we have known it is having 4 rings, that is neosamine C, deoxystreptamine, D-ribose and neosamine B. So it undergoes methanolysis, lysis by means of methanol. On that what happens? There may be a cleavage here. On cleavage 2 products we are getting, one is the whole thing, another is this one. So we are getting neosamine C plus deoxystreptamine and D-ribose plus neosamine B. So the combination of these two, that can be called as neamine or neomycin A. How the neosamine C is connected to deoxystreptamine? That is connected glycosidically. So the bond between that is O. So these it is connected to glycosidically connected to deoxystreptamine. Which part will be connected? 4th position of deoxystreptamine is connected with neosamine C. So it is obtained by methanolysis of neomycin B or C. Actually, the glycosidic bond between D-ribose and deoxystreptamine is broken. So what is neamine? It is a combination of deoxystreptamine and neosamine C that are linked glycosidically at the 4th position of deoxystreptamine. And it is too toxic for parenteral use and it is limited only for topical use. Now we will see the uses of neomycin. The treatment of GI infections, dermatological infections and acute bacterial peritonitis. It is usually combined with bezitracin or polymyxin to prevent minor skin injuries. Why it is combined? To widen the antibacterial spectrum. That's